Okay, let's see how to determine the empirical formula for a compound when you are giving the grams of each element contained in the compound. So this is similar to mass percentage, but we're taking the mass present of each element and using it to determine the empirical formula, which is the simplest ratio of the elements involved in the compound. So let's first take the mass of each element given, 0.0134 grams of iron. Let's convert these to moles. So we divide each of these by their molar mass. For iron it's 55.845 grams. For sulfur, 0.00769 grams of sulfur divided by its molar mass, 32.066 grams per mole. And the oxygen, 0.0115 grams of oxygen by its molar mass. Okay, these molar masses are coming from the periodic table. So we determine the moles of each element in our formula, because remember, formulas, those subscripts are mole ratios, not gram ratios. So for iron, we have 2.3995 times 10 to the negative fourth moles. Now, I'm not worried about sig figs at this moment. I'm taking extra digits so that I can clearly see the ratio involved. So 0.00769 divided by 32.066 for sulfur gives me 2.39818 times 10 to the negative fourth moles of sulfur. Okay, so notice these are equal to one another. That's going to help us determine that empirical formula. And then our oxygen, 0.0115 divided by 16 gives us 7.1875 times 10 to the negative fourth moles of oxygen. Okay, so what we've done is we've taken the mass of each element contained in the compound. We've divided them by their molar masses so that we know the moles of iron, sulfur, and oxygen contained in the compound. Now, what we want to do next, we want to look at the ratio of these moles. So let's focus on the mole ratio between these three elements. We can pretty easily see that the iron and sulfur are in a 1-to-1 ratio. With the oxygen, it may be a little bit more challenging to see what that ratio is. So let's take the smallest value here and let's divide it into the oxygen so that we can see what that 1 to integer ratio is. So let's go 7.1875 times 10 to the negative fourth divided by 2.39818 to the negative fourth. See what that ratio is, and we can tell that the ratio comes out to be 2.997, which is 3. Okay, so that ratio is 1 to 3. So our formula for this compound would be FeSO3, because the elements are in a 1 to 3 mole ratio. If we wanted to name this compound, it would be iron 2 sulfite. So that's how we can compound when we're giving mass percentages. Okay, so let's find the empirical formula for a compound that is 32.8% chromium and 67.2% chlorine. Okay, the first thing I'd like for you to do is assume 100 grams, which allows us to take the percentages and change them to grams. So we would have 32.8 grams of chromium and 67.2 grams of chlorine. Now, we would work this problem much like we did the iron, sulfur, and oxygen.